How will you get this? You'll graph this. First of all, your calculator should be in radian mode. How do you know? Whenever it's not specified, it's in radians. Graph, correct? Right, then your view window has to be adjusted. Cos 30t, correct? Your view window can be adjusted. Cos 30t, 30x plus 5. Because in degrees, they'll put degrees over there. Correct? Now, if you do view window, they've given you view window. 0 to 0.5 is your view window. Correct? So your maximum is 10. So you can also do view window because your amplitude is 10, no, basically. So I can have my minus 11 to 11. There. Yeah. So you have to plot this on your this on the same graph. Plot this v1, v2. So what you have to do is you have to get all the intercepts and all that. The max. So the max would be 10 and this would be 8, and then you get all the intercepts and you draw basically. Okay. So remember, whenever it's not specified with the radians, find an expression for the total voltage v1 plus v2 in this form. So what will you do is, again we'll do that complex number method. So what will you do is, this is very very important, combining sinusoidal voltages. So for v1, what's your r1? 8. What's your theta 1? 30t. For v2, what's your r? r2? 10. What's theta 2? So first thing is, when you're doing v1 plus v2, you write both this in Euler form. R e raised to 30 ti plus 10 e raised to 30t plus 5i. This is 5. Now use law of indices. So this will be 8 e raised to 30 ti plus 10 e raised to 30 ti into e raised to 5i. Correct? You can remove common. E raised to 30 ti, you remove common. What will be left with? 8 plus 10 e raised to 5i. Now use your calculator and combine this into a single function. So go to menu, run matrix, correct? Go to option, complex. So you can do, you can write 8 plus 10 angle. You can put the angle. Your angle is how much? 5. Angle is 5. You have to write this in polar form. So how much is that? E raised to 30 ti, and this is your 14.5 e raised to minus 0.724i. You combine this, so this is your r and this is your theta. Now we open the brackets. So when you open the brackets, this is 14.5 e raised to 30 ti minus 0.724i. Correct? So that's 14.5 e raised to 30t minus 0.724 I. So what's your combined? So now if you look at your combined this, so what's your combined amplitude? This is your combined amplitude. This is your combined amplitude and this is your combined phase angle. Correct? So therefore your V is equal to 14.5 cos 30t minus 0.72. That's your answer. That's your combined voltage. When you combine these two voltages, this is what will happen. What we did is we had two voltages, two sinusoidal voltages. We are combining them into a single voltage. So what we do is we write the R and theta for each of them. We write the corresponding complex number related to each of them using Euler form. Using law of indices, we break this up because a raised to m plus n, you can break it up as a raised to m into a raised to n. You can do that. You can break it up. So that's what I broke it up. I remove e raised to 30ti common. You'll be left with a complex number. You type this in your calculator. Take care that your calculator is in radian mode. So 8 plus 10 angle 5. Your angle is your argument. Okay. You convert this into single complex number r theta. So this is your r and this is your theta. So this is your r and this is your theta, which you got from the calculator. This is your r and theta. Then you open the brackets, your E and E combines. You combine your E into single power. 14.5 is your modulus, and this is your argument, and this is your final answer basically. 14.5 is the amplitude, and this is your angle.